Welcome to the viewers. We discussed the idea of open cover at first, and then we are going to the idea of compact set. At first we are going to the open cover systems. Suppose let us consider examples of a real number for open interval like this AB, and if we say this open interval of AB, this is in the interval AB, and where we know A is less than B, and which forms an open cover for real number space R. Suppose we are taking this type of systems. AB is arbitrarily defined, and suppose if we say the any type of system, suppose it is 0, whatever may be the number is, it is arbitrarily defined, I already discussed. And if we say like the number for interval 1 2, where it is 1 and it is 2, and suppose if we say another example 3 7, 1 2, it is 3 and 4 5 6 7, 1 2 3 4 5 6 7, this is 3 and this is 7. And if we say another type of interval like 4 5 and like 5 6, and if we say it is 8, then it is another interval like this 7 8, whatever may be the number is in the form of A less than B. And if we say like the interval 1 3, that is cover already 1 2, so 1 3 that cover 1 2 already we say, like 2 4, if we say interval that cover like 2 3 3 4, whatever may be 3 4 2 3, in this way. So it is the idea of covering, and arbitrarily defined as A and B, whatever may be the value of A and B, and both here A and B, where both AB are being the system of real numbers, so AB, it is the cover of real number. And now if we say in our definitions, in the sense, if the open interval like minus mm, where this m is 1 2 3, in this way, that also forms an open cover of R. But why these things happen? If for m is equal to 1, we have minus 1 1, which cover minus 1 0 and 0 1. If for m equals to 2, we have minus 2 2, which covers minus 2 minus 1 minus 1 0 0 1 1 2, in this way, etc. But it is the actual applications, if we say taking the another type of interval minus 1 half, in this way, that is a fractional interval, we can't write it, we only write this integer form. That's the covering system, which cover. There are the many types of cover, and this type of cover sometimes we may find the subfamily member. It is called the subfamily member, and this type of member, this type is subfamily, and it is subcover of R. So we find here this open type of cover, open cover, like this AB interval, and here we find another type of cover, that is subcover. It is also open cover. So every subcover is also open cover. This is our concept, and with this help of preliminary concept we abroad our idea and we are going to the definitions of open cover. Let's see what it is. Now a family we find here like this cursive H is equal to for H alpha, and if alpha belonging to the member of cup of open sets like H alpha of H alpha in X, where X tau be any topological space. We find, and topology is defined there, and this is the type of open set is known as an open cover for X if this X is covered, their union of alpha belongs to this cup H alpha. That means this is the type of set where this entire topological space in X tau topology is defined, and suppose here it is all the covering system like the member, different type of classes also there. This is the arbitrarily definitions, and if we say like this different type of element like H1, like H2, like H3, like H4, whatever maybe it is, or arbitrarily defined like H5, like H6, etc, etc. And if we say this H alpha is formed as the union of H1 union H2 union H3 dot 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 union H4 union H5 union H6 dot dot dot, in this way we don't know, and this is the covering, and where this type of set, that's the index set arbitrarily defined, and this is totally covered. If this say that is a union of this set, suppose this alpha belongs to this cup, arbitrarily defined as this type of element, and that will certainly cover the total system of X, that's the total entire spaces X tau. And this is our actual definition criteria. Actually it is totally covered. This is an arbitrarily, so we can't finish it. H6 whatever may be arbitrarily defined, and this is X totally covered the space X actually. And covered means here equals to is given, there is an improper subset, and X is also covered by this, that's why these two are equal. So we can say that is X is equal to this arbitrary space X is equal to union of alpha belongs to cup H alpha. So we are getting here some of the idea about open cover, and open cover have the finite subcover. We already give this idea of real number systems, and this is our concept of open cover. For the first definition is known as open cover, definition number 1. And if we say definition number 2, that is a subfamily like this, say here this cursive G is included in this H is called an open subcover for X if this cursive G is itself an open cover for X. Already I told these explanations of the real number systems in the cases of real number systems where I set minus m to m, this type of interval that's covered the whole spaces of real number like the form of AB. It is our simple notation 1 2 3 4 like this number all the covered. Already I explained everything, and this is the idea of open subcover. So we are getting this idea of cover and subcover in the topological field. We end our discussion today. If you like this video, like it, share it, and don't forget to subscribe the channel. Thanks for watching.